Uh, this is my talk about my new little serialization library called Serializotron, the little robot that does your serializing for you and helps with your functional programming stuff. Um, so, I went on a journey. It's a bit blurry, but there's like weird Haskell things in those little bits up there. And now I'm here to tell the story. So specifically, the story itself was the last 9 years of my life. So I was in Singapore from 2015 to 2024. That was my leaving drinks, almost a year ago now. And when you leave a finance job, the person leaving gets to pay for beer and pizza for everyone. So that was a bit confronting. It was about undone all the money. No, it wasn't as bad as I expected. But it's actually a cool photo because you get a pretty even mix of like quants kind of on the left and the strats kind of on the right. So they're all the people that we worked with. So the strats are the functional programmers and the quants are the finance nerds who do like calculations and numbers and stuff. So that's downstairs at MBFC, Marina Bay Financial Centre in Singapore. Very Singapore picture. It's parking down rain. Yep. Anyway, I'm gonna have to edit that out. Yeah, cool. So what kind of data do we use in finance? Here's a motivating example. You're going to go on a holiday to New Zealand in 3 months. And so you do some budgeting and you go, okay, it's going to be about $5,000 New Zealand dollars. You look up the exchange rate. I don't know if that's actually the current number. And you work out it's going to be 4,500 Aussie dollars. And you get worried that maybe some weird political thing is going to happen in 3 months and your holiday will become infeasibly expensive. And so you think, how can I mitigate this risk? What can I do? I don't know if people can buy FX forwards themselves, but corporations can. So the product is called an FX forward. And it's got almost nothing in it. You're saying that today is today, 3 months is what we care about, and we want to lock in that rate of $4,500 for our holiday. And it doesn't matter what the market rate is in 3 months, we're going to be handed the 5,000 New Zealand dollars in 3 months. So FX forwards are like one of the foundational products. There's literally hundreds of thousands of them live in Standard Chartered at any one time. And the reason that they're cool is that if the market, what happens? If the Aussie dollar goes really weak, you still get to have your holiday at the 4,500. So you haven't gone worse. The Aussie dollar could get stronger, in which case you could have had a cheaper holiday, but you don't really care because you're concerned about the expense. So you trade a potential gain for certainty of knowing how much your holiday will cost. And so the bank has to encode these. And if you were a bank that chose Python, like one that I'll come to in a moment, you could encode an FX forward as a dictionary. It's that simple. It's one of the simplest products. And it's just got like literally the fields that I had on the slide before. You're just saying the currencies, the amount you're buying, the amount you want to get, the date in the future, and the rate. And so you've got to store these. You have to evolve them over time. You have to fix mistakes. You have to like do the things when you get to that date. So you have to serialize it. You have to put it in a database, and you have to keep it forever. Just like the bank knows about your home loan, and they don't just forget it, and they have to serialize your home loan somewhere. Like this is all written down. So you could serialize it to JSON. And JSON is cool because you can look at it and it looks really nice. But if you have a few 100,000 of these, you're just going to repeat, double quote, sell, current, like you're repeating just so many characters over and over and over for structure that's just all the same. And how does JSON do numbers? Does it actually have a double? It does, doesn't it? Yeah. But it's like scientific notation. Yeah, but it's like it's a double, and maybe you want that notional to be an integer. Like you sort of lose control of some of these things. And so it's cool, but it's not fantastic. If you're like the bank that chose Python very strongly, you'll just pickle it, and you you'd probably pickle the object or something and do something smarter, because there's still a bit of duplication there, but that's cool. Pickling is another format for serializing. And there's this weird parallel between everything in finance and games. I think maybe finance is just a type of game, because like you have exactly the same problem that if you turn on your PlayStation 1 and try to open up your game from a year ago or 10 years ago, it has to load. And if you try to put your save game on a newer console, it has to load. Like the users will fly into a rage if you can't load your game. Just like in finance, if the bank lost your FX forward or your home loan, you'd fly into a rage. Or if you tap your card to pay for your 50-cent fare on the bus, you fly into a rage. It's very immediate, and it has to be perfect, and the data has to be like perfect all the time. There's never no possibility for ambiguity. So yeah, you could pickle as well. But so the bank itself. Oh, sorry. I'll start with this quote. That's the original version that organizations pretty much end up designing systems that look like their org chart. And you can see a really cool example of this on that blog post called Bank Python, which I believe is about Bank of America Merrill Lynch, who have millions and millions of lines of Python code to do all of this stuff. And when you read that post, it describes the market data system, and I can map that to something at Standard Chartered, and the trade data system, and they use pickling like nothing on earth. You can't edit the source code for that system with a text editor, because the source code is pickled in the database. So there's a custom editor to load source code. It's just, they've taken it to the moon. Like they grabbed Python, I think 2.7, and they just go, because banks are basically black holes of technology, and it just, yeah, they locked into that. So at my previous bank, we had a proprietary internal serialization format, which was absolutely mind-blowing at what it could do. You could be in the REPL and get a closure, save that to a file, email it to a trader, have them double-click it in Windows, and it would launch and run, and then write market data to something that you don't have permission to. So it could do a lot. Like it can do a lot more than what I'm going to do after this. But it had some quirks. Other people would say, oh, can we see the JSON for a trade? And our big boss was like, no, we don't do that. We do our format. That's it. If you want to do a number, you have to use mu to do it, which does make sense in like a political kind of sense, that you want to control where the expertise is, but it's annoying because there are other systems, like there's Java systems and Python and other stuff that people would like to look at. And the most exciting production incidents were caused by like a single bad value that was serialized, that then so there's like a batch that runs every day that loads millions of live trades and calculates a big number, and that thing would get completely blown up by a single trade that some lovely person had written a weird value into without realizing what they were doing. And I had to write a lot of code that also was very, very defensive about what I was currently doing, and then thinking about what any future version of myself might do, and be wary about what anyone might try to load in the future. So kind of basically like the saved game problem, like you always want to be able to load your games. A user should never go, oh, I can't play. So mu had a kind of, so types evolve, but the data outlasts the code. I think the closure guy is into this kind of idea that data should be the central thing that you think about. Old values, as I was saying, can load incorrectly. There's maintenance costs, like paying me to do stuff. And mu decided to serialize the index of a constructor, which I'll come to on the next slide. But you have this problem where you might have a foo that has an A and a B, and someone comes along and goes, I don't like this. This is crap code. I'm going to flip these around, so B and then A. And that causes problems. I've got the example on the next slide. And we get things like this, where there was a B, and we don't use it anymore, but we cannot remove it. So there's unused, do not use, please for the love of God. Never, and there's also like basically the training for new Strat developers was you never reorder these if it's something that's being saved, and you always add new things on the end, otherwise you'll break everything that came before it. And so the example of that using a pseudo Python syntax is that if you wanted to serialize that, you could send it to a list and say it's a sum type. A is the first thing, so that's index 0, and it's an int, and it's 42. But if you flip the things around and then run the new code, you could come up with exactly the same serialized value. But A and B are obviously different. They could be different strategies for how you're going to run your process, or different calendar things. There's all these calendars in finance, so it's not great. And I thought about this over time. I thought about this over time, that the binary format was internal, and wouldn't it be cool if we used a more friendly binary format? So there's Protobuf from Google with support in all of those languages, even MATLAB, which is wild, and Perl. Yep.
They officially supported Google themselves publish the Protobuf libraries for that set of languages?
Yeah, okay. I think so. Yeah, I found that list earlier today. Although even the Haskell one seems to be from Google, but it doesn't seem to be like first class supported. So, but the format's been around for ages. They use it for all of their internal RPC type things. So obviously they have many languages in their ecosystem. I guess they'd have Python, Java, C++. So it communicates between languages. And I had an idea about how we could do this quite easily using generics. And I thought, wouldn't it be cool to try to serialize some of the type information as well, so that then you could tell if you were loading the wrong A or B or stuff like that. So it was kind of a thought experiment from my end, like, could we do this? Would it be efficient? Would it actually be useful? Maybe it would be crap, we don't know. And you might say, well, why don't you just use Protobuf? But then you have to write Protobuf things for your types. And so you're kind of, that's too much work. Like you want your developers to be able to, make a new type that represents some thingamajig and say deriving something and just save it, and not have to do work of like listing out the fields or writing their own code gen or doing crazy stuff. So, and yeah, I do want to put more of the schema in as well, because I think it will be fun and it might help with other sorts of ideas after that. Apologies for the edit. On the night, I mangled the audio in this section, so I just wanted to show what the naming inspiration for Serializotron was, and it's the DOS game ZZT that I used to play back in the 90s. It's text-based ASCII, very cool vibes, and the save file format is SZT, which is a really convenient shortening of Serializotron, and Serializotron is the little happy robot that helps you serialize your Haskell values. This clip is actually from a much longer YouTube video by the Welds of ZZT, and I'll put a link in the description. It's a really cool walkthrough of the game in there. And back to the normal slides now. Basically copy what ASIN does for JSON and define like a class. So if you implement to SZT, then you can turn your Haskell type into a dynamic value, which is the key sort of intermediate representation. You want to be able to go backwards. You want to be able to save the file, load the file. And this one here about loading the raw value is something that I used a lot in the equivalent version in the back, because you want to be able to load something, get it in memory, start poking around, check which fields you actually have, then kind of push it into the type that you know you have now, and do some error checking while you're doing that. It's kind of like loading JSON, putting it into a JS value, and then looking through it, making decisions, and then doing something else to get an actual type afterwards. So I've written the code that does that, and it's kind of exciting. And I think it would be cool to have like lots of errors, because everything's an error, everything's failing all the time. Finance is just pure errors. It looks good from the outside, but internally it's just non-stop errors. And it would be really cool if you could capture like fields changing and crazy stuff like that. So that's relatively standard for Haskell design. But then we go, what are all the Haskell values? Like, what is the universe of Haskell values? How do we know how to arbitrarily handle a Haskell value. And if you see this SOP thing, that means sum of products, because most of the basic Haskell types are sums of products. So a product is a thing like a position is 2 integers. So that's something that you'd write in Go or Python. You just have a bunch of fields, and it's a product because you can put anything you want in each of them, like it's all the values, as opposed to a sum, which is saying one of the alternatives. So you might have a shape that's a circle or a rectangle, or in finance, you might have a calendar, which could be one of like 15 different things. Or you might have a sum of products. Is this a sum? Yeah. So this message can be a ping or data, whatever that means, but it's like one or the other. We're not having both of them. And then the data is a product. So that's literally a sum of a product thing here. So that's pretty much the shape of Haskell values. It's a cool thing to think about because when you're playing with a language, you should ask yourself, what are all the possible values I can make? And what's all the shapes of values I can make? And what's all the shapes of programs I can make? Like, can I define functions inside other functions? Can I define types in weird places? Like, it's always good to poke it so you sort of see what you can do in all parts of the code. And writing a serialization library is a great way to find out what the corner cases actually are. So, why is this not full screen? Yep. I'm not going to do GADTs because they're pretty weird. And you can't do deriving generic on that. So that kind of knocks out a big chunk of what I'm interested in. It's a pretty complicated looking type, and my focus is on things that are fairly just simple concrete values that you want to hand to another system, get some number, do something else. I think you can write a manual instance to do this, but it's you'd essentially be translating it to another type, maybe, I'm not sure. If there's any GADT experts, I'd like to know. And I guess we should support finite types as well. Mu actually supported loops and recursive stuff, but I'm not going to. So, and then this is one of those questions where you go, oh, what does ASIN do if I give it an infinite list? Like, it won't tell you anything. It'll just run out of memory and like explode. I guess because if you could actually tell if that was infinite on an arbitrary Haskell expression, you'd be solving the halting problem, which by our computer science education is like you can't. So there's no way to do this. So you just say, don't give me an infinite value. That's a silly idea. Even though that example, like, it's clear in a sense that the ones is just a little cycle in memory, but in an arbitrary sense, you can't really work that out. So, okay, so we're finite, we're concrete, we're simple. And so the first type that we'll try is the maybe. If you go in GHC and go :I and then maybe, it tells you a whole bunch of stuff, which is all a bit crazy, but that's the type there. So the maybe is there's no value, or you have a value and there's the value. In other languages, you stuff around with silly ideas like having nulls or nils or an empty string, or coming up with a string that you totally know that no user will ever type in and go, that's going to be my secret special value. Or, and I've done this, splitting a string field using a character that you totally know that no one's ever going to send in, and then using the first part as like a metadata and then the value. That's totally never going to explode. So yeah, nothing is cool, and it's some type. And it's kind of like a journey of Haskell learning as well. Like if you look at, so I think learning what EQ and ORD is like some of the first things you do. And then you start reading about lenses and you start going, oh yeah, this index stuff, that's really crazy. But then you come down here and you get this just bizarre stuff that looks like it has what we want, because it has a string maybe, and a string nothing, and a string just, and then some stuff. And so that's generics kind of handing us the structure of the type. which we don't have to read the entire thing, but it does. It actually reads relatively reasonably. So D1, I don't know why they didn't use longer words. I guess they couldn't be bothered typing. So D1 means it's a data type. There's a metadata line that tells you it's the maybe type from that module. It's in base. And they thought Boolean blindness would be awesome here. So false means that it's not a new type. So why didn't they use a type, given that it's Haskell? And that line tells you there's a nothing, and it has a unit as the thing that goes in, because you're not putting anything in a nothing. It's just nothing is nothing. And then that thing means now follows the next constructor, basically. So C1, it's a just, and blah, 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 record 0, crazy name again. There's the A. So that's the value that you can put in your just. So the information is all there. It's just, it's hard to play around with. And if you go in like GHCI and go GHC generics from and then a value, you get that incredibly short representation, which doesn't show you the cool stuff that we want, because it kind of happens at the type level, I think. So you have to write some of this style of code, which we don't need to fully get into, but you're basically pattern matching. So that's where you have a sum, which means that you would need to go recurse in both sides and just add them together. If you hit a field, which is called K1, then there's nothing in there because you've gone to the bottom of a field in a record. So you can write a recursive function to just walk through these type level bits, and the types will pop out. I won't torture you with those details because they're really squiggly and weird, but here's what my dynamic value representation looks like. So I've decided to partially make the same mistake that New did and say we'll use a 0 to mean the nothing. But I've got all this cool stuff, like I know what the constructors are, and I've replicated this in my own type that says that you've got a nothing with a unit. It's a bit messy, but and then there's a primitive int down there. And if you go to adjust, it's got a 42, which is a primitive int, and still we have all the other stuff down the bottom. So even though I'm handing you a just 42, you know what the full structure of the type is actually meant to be. People like using trees in, Haskell learning stuff. And unfortunately, this one, that tree there, like the example tree, unfortunately turns into this much of a dynamic value. Yeah, there's a bit of duplication, but it's still, you can sort of read it from the beginning like there's a sum type with a 1 because the first thing is branch, and branch is the 1, and the branch itself has got a product which is like the 1, and then, it's impossible to scroll in a talk and actually show the values, but you can believe me that it's all there. So, but we don't really want to ever look at that dynamic value because that's just an intermediate thing. To go to the next step, so our type to represent the file, it's basically just wrapping the dynamic value. And the dynamic core value has just got the things that I care about. So the primitives, I'm going to do integers and doubles and text. No string. String is terrible. Bools, words, series of bytes, because that could be whatever you want. And weirdly, like this does represent pretty much any Haskell value that you want. So you might have a primitive thing, like just a number. You might have a product, which is then a list of the values. You might have a sum type, which has an offset and a value. For some reason, I decided to treat lists specially, so you have a list, you got a unit, and then a reference, because I started doing compression and other cool things. But that's like, you can smush any Haskell value, except GATTs, directly into one of these, and off you go.
I understand why you derivation because I guess it's complicated to express the constraints, but
yep.
GATTs actually have like when they're stored in memory, are they actually doing some things that would make it hard to serialize? Like, assuming you could get information, would it also be possible to support things, or would you actually do?
Well, yeah, I think the different constructors can make a thing of a different type, right?
Oh, right.
And
so
it
actually talking about like a set of like.
Yeah,
Right,
like
okay.
because like the literal int gives you an expression int, but the literal bool gives you an expression bool. So then it's a bit.
You're looking at an
yeah.
It's kind of like what are the variables?
Yeah.
Okay.
Yeah. So I mean, GHC doesn't do deriving generic on that. I guess. I mean, maybe they'll fix that in the future, but yeah, it's a paper. Yeah. Okay. Yeah. And again, this is the gory details, but the cool thing is that you can define an instance that has a default implementation of 2 Serializotron, which then leverages more generic weirdness over here. And so you can use GHC generics from to get the value from the generic representation, but you can also write a function that walks through the types, which is that weird big thing I had before with like the colon plus colon. So that can just walk through the values, because ultimately this is just all trees of things, and you can just write a recursive function that just goes down and hits every value. So it's like, it looks like a lot, but it's just trees of values, nothing too crazy. And so the final step is the protobuf definition. And I guess someone at Google was really into functional programming or language stuff, because they put a sum type into protobuf. So that message dynamic core is like a one-to-one correspondence to the Haskell type. It's like exactly the same. So I guess internally at Google, they enjoy having sum types in all of their RPC, and that's cool. It's very handy for this because it means that, yeah, like there's the primitive values, and then the product is a repeated dynamic value. The type info, yeah, that's surprisingly short. And then dynamic value, while it's verbose at runtime, it matches. And the code to turn that into protobuf is you're just putting it in. You're just mapping it across. And that's the protobuf representation of just 42. So it's actually surprisingly short. We don't have all the type information everywhere because I have a type table down the bottom. So that's a shared table of all the types that appear in anything that is related up the top. So here we've just captured int and maybe. And we've also captured the type parameters, which turns out to be exciting for other reasons I'll come to later on. So that's actually pretty short. I then tested the A/B flipping example. So this is like a moving forwards in time. So the first person writes A and then B. They save that value. That's all cool. Then someone comes along and says, no, I want B then A, because that makes sense to me. And when you actually load that, it says we expected constructor B A but found. Oh, sorry, we expected B comma A, but we found A comma B. So we can actually see that the constructor's flipped because we're just writing them down. Like it's not. Yeah. So yeah, exactly. So even though we saved just the A42 value, we've actually also saved the A and the B and everything else that you might have needed to get that time. So there is obviously an overhead for that. But if you think about values that you want to save long term, it means that you've got heaps of metadata, which is, I don't know, cool, because like how can you guard against someone doing that? Like it seems logically to a Haskell developer, you might go, yep, the order, whatever, it's just names, it doesn't matter. So it's the code is real, it actually does something.
Carlo, would it be possible, examples here, you've got type information about
Yep.
the constructors, the number of constructors, their names,
Yep.
and the types of the arguments to the constructors.
Yep.
Would it be possible, in some cases, obviously not in all, but if it's just a simple I'm swapping the order,
Yep.
you can detect that, oh, well, the order changed, but otherwise the A has the same parameters, the B has the same parameters as it did before. Could you just tolerate those scenarios?
Yeah, totally. Because like the error message was literally saying, I expected B comma A, but I found A comma B, and it knows that it's A with an int and B with it. So yeah, you could have that as a warning case instead. That would be totally cool. Yep, which would be better for, I don't know. It depends how angry you want to get the person who flipped the constructors. Like, and
it seems like humans are going to do things, and maybe AIs as well, going to change the orders of things without necessarily changing any of the meaning. And it's a matter of policy as to whether you want to be strict and reject that, or to observe that actually everything still lines up and we can just tolerate and move on.
So I guess weirdly I've encoded the wrongness of what I saw at the bank into this, but yeah, that makes more sense that we would just say if we get the right number of things and everything matches, and then we find the name that matches, then we should just load that name really. So yeah, that's cool.
Well, I think you should at least provide a policy switch on the library interface to say, be strict, or else, if the situation is recoverable, then recover.
Yeah.
Does remind me of this strict thing. Their thing is they just have and they make any changes to their API, they just add an extra from and to.
Yep.
So there could also be things because if you do want to change food, kind of want some way forward, right? So in here, for example, if I had to put A or B or C, it would also complain, right?
Yeah. I think so. I have to check.
I mean, it's like it's good to have that instead of something gets in the wrong spot.
So yeah, the Stripe blog posts about this are also really cool because they're dealing with the same thing that that's the thing with the bank, that you've got so many copies of the code running and so many versions, and you've got some weird production system over here that's running a version from 3 years ago and they're refusing to update and they complain about not having funding and blah, blah, and it just goes on. And so the upgrade paths can be brutally slow, but that's the same with like Stripe, that they, like if there's maybe, I don't know, like they've got a physical terminal things as well, don't they? Like you can't force every cafe to update their things immediately to just make everything perfect. It's
on their server side.
Yep.
So they don't have to be that, they don't have to be forward compatible with code they wrote from 10 years ago.
Right.
But I think in the bank situation, you add more than you do A or B or C and then write that.
Yep.
So you read that they only have A or B, what are they supposed to do?
Yeah.
Well, I mean, it's a lot less close.
Yeah.
I mean, I don't know. There's not really much of an answer to what if I can't change it?
Yeah. So this is real performance numbers from my job, except I've changed the names so that you can't tell what we do at my work. So my favorite example is FizzBuzz95, which I think is a fantastic name for this particular model. So the JSON is about 600 meg. There's a serialization library called CBOR, which is a binary format that's really fast. It's pretty cool, but it still turned out 300 meg. And my thing produced half a meg. And you look at this and go, have you done something terribly wrong? No, it does round trip. Every single thing here round trips. It is like coming out pure equality. But there is a lot of duplicated nested structure, I guess, in some of these things, which could be a thing to optimize on the other end, but on the other hand, we have there's reasons to have this. So I didn't actually explain how I do this, but when you're walking through the data, you can look at a value and say, have we seen this tree, this chunk before? And if we have, you can store a reference instead of the whole value. So you can just make a table, and I guess the word for that is like interning. So I know that Go recently added string interning, like that's for runtime stuff, where if you've loaded like a CSV file with a bajillion names, and it's like repeating like John, Smith, Jane, Bob, whatever, you don't need to store those millions of names in memory duplicated. You could store the unique names, and then everyone else just has a pointer. So string, I think Java does it, Go does it. I've got no idea about other languages, but it's okay. They all do this. Okay. Do they?
Sometimes it depends on the size of the string. So small strings, sometimes small, some threshold will be interned, and larger ones will reside in memory.
Yep. Yeah. Oh, and I've also not as many as I expected, but yeah, there's a few key sum types, and then lots of like basically sets, I guess. But yeah.
So there are some cases here where the Serializotron is an order of magnitude bigger than the SQL or the JSON. The first one, first column.
Wait, which? Yeah. Yeah, it's slower because it's doing more work.
Sorry, right.
Yeah, sorry, it's
right.
time to serialize, time to deserialize, and time the size. Yeah. So there's a trade. Yeah. So there's a trade-off, obviously, because if you want it to be perfect, you could walk through the entire thing, computing hashes everywhere, come back in another pass and do, so it depends how much you want to blast through all the code. And so a lot of the optimization is based on giving hints to be able to very quickly stop and say, I know that the rest of this I've already seen before, so I can just skip it completely. Because if you're a computer, then reading bytes takes time. You have to wait for it to come from memory, comes into a register, you do stuff, and then you send it back. And, it's always back and forth. So I'm quite happy with how this turned out. The compression stuff turned into more excitement than the actual serialization part itself. And it's really cool to sort of get a really deep feel for the kind of values that your system is actually playing with, which is designed by more mathsy people, and then I'm coming in and looking at more the core sort of memory. And there's a bunch of other cool things you can do if you're interested in what your memory is doing, like GHC debug brick lets you connect to a Haskell process and list the thunks and look at what's in memory and count how many things there are, and there's all kinds of crazy things you can play with. So, yep. I do that as well. So I didn't mention it, but the SZD, my serialization format, does the protobuf and then runs, I think, gzip or something else on that binary as well. I learned that from, I think Parquet files do this as well. I think they do like run length encoding, but I think then they do a compression on top. Because basically the compression algorithms are so good and so fast, so it's like free to just blast that over the top if why not, right? Yeah. So you do like as much as we can with our sort of chunky data, and then whatever's left, like it's not worth putting the effort in. You can just give it to another library. So yeah, so I guess
file size column is also compressed.
Yeah, so they're automatically compressed, and so
you. Are the CBOR and JSON compressed, or are they raw CBOR and JSON?
That's a little bit dodgy. Yeah, so the JSON is the raw text that you get. So you could gzip it, but yeah, well, but the CBOR format, that's what that binary format is. So that's representative of like the size. So
yeah. A lot of CBOR objects would be still quite compressed.
Yeah. Yeah. Oh yeah. Yeah. Cool. Yeah. So it's all pretty. It's fun. So where are we? And I'll admit that I did ask an AI to make the emojis for this, as I do in our weekly meetings at work. So we, or maybe me, I've thought about serialization. So this is inspired by like years of dealing with this stuff at the bank and seeing how it goes wrong and wondering what we could do a little bit better or a little bit different. I think choosing the binary format is pretty cool. You get to leverage a lot of other people's work by using a popular format. The intermediate representation leverages generics, and that's also like really cool. It's similar to how the JSON libraries do this, and I guess CBOR as well. And there's all kinds of fun opportunities for compression, deduplication, shallow identifiers. Like there's just a lot you can, like data is fun to stuff around with. And so where do we go with this? I wish that I had the big brain to actually come up with this first, but I realized this after I'd done all of this, that I can go from the Haskell type, the source, the code, to a dynamic value, to the protobuf, and then why don't I just hand this to TypeScript and code gen TypeScript to reflect the types. Oh. So then I could have a TypeScript front end that can have code generated values based on the Haskell side and not have to write custom serialization in between or basically deal with anything else. And when your sort of more mathsy colleagues maybe rewrite some stuff, you just hit a button, regenerate the protobuf bits, hand it to a TypeScript generator, regenerate it there. Oh, there's going to be a nightmare with versioning and migrations, but we'll come to that. I've started messing around with this, so I need to learn TypeScript properly, but you can just walk through, like you see like the module name and the type name, and I don't know TypeScript, so this could be really, really dodgy, but yeah, you can just walk through protobuf because there's a JavaScript protobuf library. So import proto.js and off you go. So that's better than having to rewrite a full binary custom format parser in TypeScript again. We can just immediately do this. I've done a Go and a Python prototype just as like a throwaway thing, and it loads values and it's pretty cool. This is my last slide. So yeah, the inspiration was the closed ecosystem, and I thought, how can we do this better? I think protobuf is good. Dynamic values are a nice intermediate thing. Generics are pretty cool. They let you walk through the shape of your types and work out what's in there. And if we just add a little bit of spice, you can have type-aware validation. We can interop with a lot of other languages a lot quicker. And maybe we can do schema revolution, I'm not sure, or we can at least be safer or have better ideas about, like what Trey's just said about, doing, what's the language from the guy from Software Unscripted? Is it Rock or something? I think that language does structural typing, which sounds like what this is, that if the shape matches, then the types are equivalent. So in Haskell, if you have like a foo and a bar, and they're all the same, Haskell will say, no, these are different. But in, I think it's Rock, if you have foo and a bar and they've got all the same fields, you can... Oh, right, cool. Yeah, fantastic. So, yeah, so other languages have this kind of idea. In my case,
where that breaks down is if you've got a sum type with, for example, two constructors
yep.
With different semantics, but the same arguments to those constructors.
Yep. And then it doesn't know which.
Then won't know which is which.
Yeah.
So it just has to include the name of the constructor and the type.
Yeah, that's
yeah.
That's how you can get into the structure.
Yeah. Cool. Yeah, cool. So yeah, and I've got some other ideas about code gen and compression. I've got some command line tools to deal with the stuff. And so yeah, it's on GitHub, it's open source, because I've been doing it in my own time. I started this ages and ages ago. It just takes so long to get things done. And I think it might soon be useful at work, but I'm not sure. I'm still kind of experimenting. It's because if you do serialization, it has to be really, really right. You can't I don't want to introduce badness into an already difficult space. So yeah, that's it. We're good.
Thank you, Carlo.
Yep. Yay.